No, Elijah, to answer your question, I've not updated Power School since I put in the grades over the weekend. I've been checking over people that have been doing their work a little bit late and putting in scores, and I'm almost done with that. So probably by the end of today, by 3 o'clock, I'll have grades updated. But before that, probably not. But I will be updating that hopefully today. There was a couple questions about GCF and LCM that I just want to go over really quick before start science. There's a question where on your quiz you had a one composite number, so 4, and then one of them was a prime number, 7, right? You guys remember that one? So that's one that a few of you guys got wrong, a few of you guys asked questions on. So we're going to do an example one. Can you guys see that all right? Okay, so
yeah,
we're going to find the GCF of 5 and 8. So we're going to list the factors out the same way we normally would, well, our factor tree. So what numbers multiply into 5 and 8? Sorry, what number multiplies into 5 and 1? What am I trying to say?
nothing. Just
Okay,
one.
let me answer it. Ask this again. What numbers multiply into 5?
1.
1 times 5, right? It's a prime number.
Yeah.
Oof, I'm already messing up my thing. Okay, so we have 5 and 8. So if we're trying to do our factor tree, then we would just circle the 5. Sorry, I messed up above that. Ignore that. But we would just circle the 5 because it's already prime. The only numbers that multiply into it are 1 times 5. What about 8? What numbers multiply into 8?
2 and 4.
4 and 2.
2 and 4. We would circle the 4. And then what goes into 4?
Bye.
What multiplies into 4?
2 and 2.
2 and 2. Okay, so if we were to do LCM, GCF, and list this out. So we have our factor trees, and then over here we have LCM and GCF, and we're going to list them out. I'm going to list the factors of 8 first on the LCM part. Okay, so we've used all the 2's that multiply into 8. Is there a 5 to match it with?
No.
No.
Nope. So then we put our 5 on top. Now on this, we can find our LCM from this. We can multiply 2 times 2 times 2 times 5 and get our LCM. But how do I do the GCF? Is there a way to do that? Do we see anything to multiply?
5 times 1.
There's not even a number on the GCF, right?
Yeah.
So that's the only problem with this method of doing GCF. There is one other way, well, there's a few other ways to do it, but there is one other way that's gonna make the most sense for problems like this. So the other way to do it, let me get a bigger, is to legitimately list out the factors, all of the numbers that multiply into the 2 numbers. So let's start with the number 5. What numbers multiply into 5?
1, 5, and that's it.
Just 1 and 5, right? So 1 and 5. So if we were to list them out, all we'd have is 1 and 5. Now, what numbers multiply into 8?
2 and 4.
Okay, so we have a 2 and 4. What else?
And a 1 and 8.
Good, and 1 and 8. Those ones still multiply into 8, right? So now we have all of the factors of 8 and 5 listed out. Now we need to find the only factor in this case that it has in common. What's the only thing it has in common?
1.
The 1. So our GCF is 1. The only number that it has in common when you list all the factors out is 1. So if you end up with a problem like this and there's no GCF on the bottom line, that means that the only factor it has in common is 1, and 1 is your GCF. Does that make sense?
So it's never going to be a 0?
No, it will never be 0, because if you multiply anything by 0, what do you get?
0.
0. So it can't be a factor. 0 can't be a factor of 8 because if you did 0 times 8, it would be 0, not
So-
8, right?
If we don't have anything on the bottom, it's always going to be 1.
Yeah.
Okay.
Are we doing science yet? Or is
Yeah,
it too
we were
early?
just doing a review so that there are some questions on one of the problems for the math. So we're going to go on to science right now.
Okay.
Okay. For those of you that were asking questions, did that help? A little bit?
Yeah.
Okay, good. All right. Let's go ahead and go on to science. We haven't wow. I really am struggling to talk today, guys. On Google Classroom, I posted an assignment. I'll share my screen with you guys. It's called thermal energy, I think. What do I call it? Thermal energy quiz. So we're gonna do a quick PowerPoint on thermal energy. So if we scroll down to the science part of Google Classroom, it's this thermal energy quiz. There's a PowerPoint that you can pull up to help you out with the quiz, and then the quiz you guys are going to be taking on your own because I don't think we're going to have time before you need to go to art. So essentially what we're going to do is I'm going to just kind of quickly go over this PowerPoint with you. That's why I also gave you access to it, so you can go back to it. Because I don't think we're going to have time to really talk about the quiz before you take the quiz. Does that make sense? We're just going to go through the PowerPoint. You're going to have to do the quiz on your own, and then we'll go over it tomorrow in science.
Okay.
Okay?
How many
But-
questions are there supposed to be on the testing?
I think there's 10.
Oh.
But I'm going to give you guys a second chance to take it if tomorrow you guys are like, holy cow, I did really bad. Okay? Because we don't have a ton of time. So I'm going to start going over the PowerPoint. Can you guys see the thermal energy PowerPoint? Yes, sir.
Yes.
Alrighty.
Yeah.
Let's go ahead and get going. All right, so first off, today you guys are going to be able to explain how thermal energy or heat energy can be transferred by conduction, convection, or radiation. So there's 3 ways to transfer that type of energy. So like actual heat. So thermal energy is the same thing as heat, like if we started a fire or rubbed our hands together. Okay? If you don't have your mic muted, go ahead and mute it for right now. Thank you. Alrighty. So essential questions, the stuff that we're going to go over today is what is conduction and how can heat be transferred through this process. Same thing with the next one. What is convection and how can heat be transferred through this process? And the last part, what is radiation and how can heat be transferred through that process? Okay, so those are the questions we should hopefully be able to answer by the end of this. So first off, conduction. Conduction is the transfer of heat between 2 parts of a stationary system caused by the temperature difference between 2 parts. We're going to go more in depth on these later. It's just right now the review of, what's it called? The vocabulary. So that's what conduction means. And then the next one, convection. The transfer of heat by the circulation or movement of heated parts of a liquid or gas. Convection is more of like boiling water type of heat. And then our next one is radiation. It's the complete process in which energy is emitted by one body, transmitted through an intervening medium or space, and then absorbed by another body. And that's legitimately like actual radiation, like the radiation of heat through things. A lot of time, I might be wrong about this, but let's assume I am. I'm pretty sure that the heat that heats a building is radiation heat because it's made in your generators, right? Transmitted into a space, and then the heat is absorbed by our bodies because we're cold. Okay? Our next slide. Conductor and insulator. So these are 2 types of things that can give or take heat. So in a conductor, electric current can flow freely, so it can go back and forth from things. In an insulator, it cannot flow freely. So metals such as copper typify conductors, which means that it's usually conductors, while most non-metallic solids are said to be good insulators, having extremely high resistance to the flow of charge through them. So a conductor is something where the flow of heat and electricity can go really easily through things. And then an insulator is basically where it stops. Like the heat cannot make it through whatever it's trying to get through. Okay. Next slide. Oh, here we go. Simply stated, most metals are good electrical conductors and most non-metals are not. Metals are also generally good heat conductors while non-metals are not. So if you consider, let's go with, like, think of like any metal. Like if you're in Phoenix and there's a railing next to you, is that going to be really hot if you touch it in the summertime?
Yes.
Probably. Yeah.
So that's a type of metal that's a really good conductor. So the heat is coming from the sun and it's being absorbed by this metal, which means it's going to get really, really hot. So it's a good conductor. Whereas something like, let's say, what's a good example? Like cloth. So let's say you're going to go sit down in Phoenix on like a cushion. Is that going to be super duper hot?
Not as hot as the rail would be.
Yeah, not as hot as the railing would be because it's a non-metal. It's not going to absorb the heat as well as the metal would. It's an insulator.
And concrete is like a rail too, because it.
Yeah, I was going to talk about concrete, and I was like, no, the concrete gets really hot, so that would not have been a good example. Okay. Does that make sense? Something that conducts heat is going to make it really hot, and an insulator is going to not make it hot. Alrighty. Next part. So heat, which is thermal energy. Thermal energy is what we call energy that comes from the heat. So for example, a cup of hot tea has thermal energy in the form of kinetic energy from its particles. So the particles are all moving around inside the tea and making it hot. So it's giving off that thermal energy, the heat. And then when you pour some milk into your tea, some of the energy is transferred to the particles in the cold milk. So it cools it down because you added something a little bit cooler. You're taking away some of that thermal energy, making it cooler. All righty. Next part. Then what happens next? The cup of tea is cooler because it lost some thermal energy to the milk. So we cannot really talk about thermal energy without talking about temperature too. They go hand in hand. The temperature goes up and down because thermal energy is added or subtracted from whatever is happening. Okay? So, they just put a lot of words on these slides on this one, didn't they? The temperature of an object has to do with how hot or cold it is. Temperature measured in degrees Celsius. The United States is the only country in the world that does not measure things in Celsius. We use Fahrenheit, so it's 10 degrees Fahrenheit. But most other countries, pretty much all of them, use Celsius, which is just another way to tell temperature. It's like if we say that it is 50 degrees outside, we say 50 degrees Fahrenheit. To them, that's about 20 degrees Fahrenheit. So that's the difference between Celsius and Fahrenheit. Celsius is usually a smaller number.
Isn't that the metric system?
It is the metric system, yeah. The U.S. is pretty much the only country that does not use the metric system, which is really sad because the metric system is so much easier to understand, but we just don't do it.
And there's some other little places that use it too.
Yeah, there's a couple places, but not a lot. Most of them are U.S. territories. So then we have two examples between to see the difference between the heat of something and the temperature of something. So a swimming pool is at 30 degrees Celsius, and that's going to be at a lower temperature than a cup of tea at 80 degrees Celsius, which we can clearly see. 30 is less than 80, correct? Yeah?
Yeah.
Then it says, but the swimming pool contains more water, so it's actually storing more thermal energy than the cup of tea, just because it has more water. Doesn't matter the temperature of the water, it just has more, so it has more energy in it. Okay, that's the difference there. The temperature can be super, super hot, but if there's more water somewhere or more tea, it's going to have more energy. All right? Next up, our next, what's it called? Example. To boil water, we must increase its temperature to 100 degrees Celsius. It takes longer to boil a large beaker of water than a small beaker because the large beaker contains more water and needs more thermal energy to reach 100 degrees Celsius. So, in other words, if I have a gallon of water, like the big jug of water, versus one small cup of water, it's going to take a lot longer to boil that whole gallon of water because you need more energy to heat it up than just the small amount of water. Okay? How we doing? So, following a little bit?
Good.
Doing all right?
Good.
I know it's kind of a lot of information. That's why we're going to review tomorrow as well. Okay?
Could we wait till tomorrow to do the test if we like that way we can have it fresh in our minds after tomorrow?
Yeah, that's fine.
I'm
Okay.
just listening to you, and then I go to my PowerPoint and I get my answers.
All right, that sounds good. Yeah, if you have the quiz up right now, you can be getting answers as we go even too right now. It's totally fine. The next part says, let's see three different important, wow, really can't talk today. Let's see three very important forms of heat energy. So there's conduction, convection, and radiation. Those are three important types of heat energy. The first one, conduction, is when a substance is heated up, its particles gain energy and vibrate vigorously, so really, really quick. The particles bump into the nearby particles and make them vibrate more. The particles then pass the thermal energy through the substance by a conductor from the hot end to the cold end. So that's something, basically you're heating something up, like one substance, and all the particles inside are going to start going really, really fast and make it hot. That's essentially what conduction does. Okay? So substances that allow thermal energy to move easily through them are called conductors, like we talked about. Metals are good conductors of thermal energy. And then substances that do not allow thermal energy to move through them easily are called conductors. Wow. Insulators. Sorry. Air and plastics are insulators. So plastic doesn't really allow heat to pass through it super easily, but metal does. All right. Our next one. Here's kind of an example. If we have a metal rod, like just a piece of metal that's super long, if we apply heat to one side of it with like fire or something, it's going to start heating up on this side. And then the longer you're heating it up, the more of the particles are going to start vibrating against each other and start heating up the rest of the rod until finally thermal energy has moved all the way through the rod, but it's always going to be hotter where the fire is hitting versus the other end where it's not. So if you think about when you like roast marshmallows, where you stick, because you're essentially sticking a piece of metal in fire when you roast marshmallows, right? The end of it, you always got to be careful when you touch the end that's been in the fire because it's super, super hot. Do you guys agree with me on that?
Yes.
Yeah.
Yeah. So that side is going to be super hot. And have you ever noticed that the longer you leave it in the fire, that it slowly gets hotter and closer to you?
Yeah.
Yeah, so that's conduction. That's that type of heat energy. It's going from the end of the rod and slowly heating up the rest of it. So that's conduction. Okay, our next one is convection. This is when particles in liquids and gases get warm. They become less dense and they rise. And the space is quickly replaced by cooler particles that are less dense because they're heavier. Thermal energy is transferred from hot places to cold places by convection. So our example, if we think about a liquid, if we're boiling a pot of water, notice how the liquid with more thermal energy rises and particles with less energy fall. So it basically goes in a circle. The hot particles are here at the bottom, and they rise up and are replaced by the cold water that goes to the bottom so that it can be heated and move to the top. And more cold particles can go to the bottom and rise to the top once they're heated. So it's kind of a circular motion where the ones at the bottom get heated and the ones at the top stay hot once they're hot.
So
And
kind of
that's how
like
we
off
boil
of
it.
Moby,
Say it again?
and like kind of like off of what Moby and them said on that video.
Yeah, they probably talked about it in Brain Pop at one point. Yep. And then if we think about gases, and we think about how, if like, let's say you're in a house and you have 2 stories, like the bottom floor and the second floor, typically it's hotter on the second floor. Have you guys ever noticed that?
Yeah.
Yeah.
It's
So
because
that's
the heat rises.
heat rises, exactly. That's convection. So the heat in your house is going to rise to the top of your house and just kind of sit there while the heat on the bottom, well, the cold air on the bottom is getting heated up and goes to the top. That's kind of why heat rises.
2 levels.
Huh?
Wow.
There's no, it's hot for me at nighttime. I have
I
2
did
levels.
not
in
hear
my
what you said, Charlie. I'm sorry. Okay. Ready for the next part?
Yes.
Alrighty. Radiation. This is like getting heat from the sun. So all objects transfer thermal energy by infrared radiation. The hotter an object is, the more infrared radiation it gives off. No particles are involved in radiation, unlike in conduction and convection. This means that thermal energy transfer by radiation can even work in space, but conduction and convection cannot. So radiation is just like the heat waves going through the air. It has nothing to do with the particles inside objects being heated up or moving around. So the best example of this is the sun, because even though it's super far away, you can still feel the heat from it because the radiation is coming from the sun and hitting us down on Earth. It's just not as hot as if we're on the surface of the sun because it's traveled so far.
Then how come it's hotter in Phoenix than here?
Because you're closer to the equator.
Oh.
Yeah. The equator is the point on the Earth where you're farthest out, right? Because the equator goes around the outside of, or directly around the middle of the Earth. Yeah. So you're technically closest to the sun near the equator.
So Phoenix in California?
Yeah, they're pretty close to the equator. If you think about like Central America, so like the place in between Mexico and South America and Brazil, that area where it's a lot of islands and stuff, it's super hot there like all year round because they're always like the closest to the sun. They're pretty much directly on the equator.
Oh.
Okay, so yeah, the heat that they're getting there from the sun is from radiation. It's radiating from the sun to the Earth. Okay? And I think that's it.
I got all of my answers in just one thing.
Good. So
I went over it twice.
good. You guys, yeah, you can do the thermal energy quiz right now if you want. If you don't do it today, we're going to talk a little bit more about radiation, probably watch a video right at the beginning of science tomorrow, but you're going to have to finish it by Sunday night to get your grade, right? So just make sure if you wait that you actually go do it. But you can do it right now if you'd like to. Real quick though, I'm going to show you guys how to get into art because you have art in about 15 minutes. I know I kind of showed you guys earlier, but I'm going to do it again because I have the actual code this time. So I'm going to share my screen, show you how to get into art. Probably didn't need to unshare my screen. So in order to get into art class, which you are getting grades for, so you need to make sure that you're going to art class. You just open up a whole brand new tab, okay? And then you're going to Google Meet, okay? just type in Google Meet and hit enter. It takes you to this, and you can click on the website meet.google.com. Then it's going to take you to this where it's like, now what? Lots of things to click on, but in order to go to Ms. Pontel's meeting, you click join or start a meeting. You're not starting your own meeting. If you're starting your own meeting, you're going to create your own nickname and give that nickname to people to get into your meeting. But Ms. Pontel already has a nickname for your guys' art class. It's Bullpups 6 Art. Okay. So at about 12:57, 12:58, you're going to need to go through this process, go to meet.google.com and enter Bullpups 6 Art. And then you'll hit continue and it'll log you into her meeting and you'll be in her art class.
What time is the class?
At 1 o'clock.
How long is it?
I want to say it's between 45 minutes to an hour, but I really don't know. I have not been to one.
Okay.
Has anybody been to one?
Yeah.
How long
Yep.
was it?
No.
What's the code called again?
No, I don't
I'll write
keep
it in the
track of
chat
the
for you
time.
guys to. You can write it down, okay? Bullpups.
Okay.
Art.
Bye. I already got it done.
Alrighty. Make sure you guys go to art. I'm gonna stay on until 1 o'clock, so 15 minutes, and then kick you guys out because you're gonna